Welcome. Last week before Thanksgiving, we're right there, guys. This is it. Um, Went to the movies this weekend. Saw Red One. Loved it. New Christmas classic for me right there. Santa Claus gets kidnapped, and Dwayne the Rock Johnson is the chief of his security team. And they have to go find what happened to Santa. So it's a very different look at Santa. Santa's kind of buff, working out all the time. Got to keep in top shape because he burns like 43 million calories in one night. He says he's got to carb up. It's all those cookies. But it was very entertaining. I enjoyed the heck out of it. I liked it a lot. So, a lot of movies coming out right now. I need a week off of school just so I have time to go see more movies because like Wicked's going to be out this weekend. I want to see that. Gladiator 2. I want to see that. Oppenheimer's out. We're going to be out next weekend. There's just all kinds of movies out. There's several others I didn't even name. Whew, a lot of good stuff. So, all right, where's the rest of us? We got eight. We got eight. We're gonna go ahead and get started. Just because it's moving on. Time is moving on. Yeah. Anyways, let's go ahead and pull up our weekly stuff here. See what algebra is going to look like for us. All right, let's go to our grade screen as usual. And if we scroll down to the bottom, I've kind of lightened the load here for the last month. I like to kind of give us a break going into the holiday season. So we only have one lesson each week. Look at this. We got solving exponential equations on unequal basis today. That'll be fun stuff. We're doing that today. Then we have a break next week, and then we have a very short time when we get back. We have graphing exponential functions the first week after Thanksgiving, graphing logarithmic functions the second week after Thanksgiving, and then the third week is our semester exam. Like, wow, that's it. We just got 3 weeks left after Thanksgiving before the semester's over. Because Thanksgiving is so late this year, being the 28th. That's the latest Thanksgiving ever is. So, very short amount of time left in the semester. So, and I'll mention the semester exam. I got to look at the schedule. First period exam, 9:15 on Wednesday, December 18th. Okay. Let me reemphasize that. The first period final exam is at 9:15 on December 8th. Wednesday, Thursday, Friday are finals that last week, 18th, 19th, and 20th of December. And 9:15 on Wednesday is when this class meets. Let's see. You have to have 4 fewer absences, 4 fewer tardies, at least 75% grade, no zeros in the grade book, no fines or fees, but we don't have fines or fees in here. So, and you cannot have more than 4 absences in advisory. If you have more than 4 absences in advisory, you're not exempt from any class. You can't exempt any class at all if you have more than 4 absences in advisory. So hopefully you've been going to advisory, been filling out the grade check, all that necessary stuff. You guys are seniors. I'll bet you've taken care of that. Yeah, Algebra 3 is a class you can be exempt from. So I was just double checking the graphic there. So you can be exempt from this final in December if you meet all those qualifications. So, yes, the meet will be at 9:15 because there's another final like at the 7:15 and they give them extra time. It's not just an hour and a half. It's like an hour 50. So, if you have a 0A class, that goes from 7:15 to 9:10. They give you an hour and 55 minutes for finals. So our meet starts at 9:15 and you'll have till 11:10 to finish the final. So you have almost 2 hours for the final. And of course, if you finish earlier than that, Merry Christmas, log off the meet, go about your merry way. But that's what we're looking at. And I will remind it, I'll put this in our Google Classroom. And as we get closer, there'll be more and more reminders of that. So you don't have to remember that today necessarily. Just know that's how it's going to be. semester final will not be available until that class time, and you need to be here to take the final during class live there. So, all right, let me go back to our curriculum so we can look at our lesson for the week. 4.04, solving exponential equations with unequal bases. Now, see, we talked a lot last week about if we have them with the same base, we can drop the base and just set the exponents equal to each other. But what happens if they don't have the same base? Last week we rewrote them in the same base, but let's see what happens with this week because it may be a little bit different for us to get this working right. So, uses of logarithm with different bases. So when you turn 16, you decide to put $50 in the savings account so you can put $2,500 down payment on a new car someday. If the account has an interest rate of 3% per year and is compounded monthly, how long is it going to take that $50 to turn into $2,500? Will you have enough money by your 18th birthday? I'll tell you now, there's no chance. You have to put more than $50. A equals P times 1 over R to the NT. Now, we had this equation we've looked at before, but let's put this in our notes again. Let me get our note screen up here. Okay, so if we would put in $50, that would be our P. That would be the principal. That would be our starting amount. And the R is the rate. R is the rate, and it's 3%. But we need to write that as a decimal. So that would be 0.03. The number of times, they said monthly. So 12 times a year is our N, the number of times a year that we get our interest. And then time, we got 2 years, right? Because they want to know by it's your 16th birthday and you put $50 in. So they want to know by your 18th birthday where you have enough, the $2,500 for a down payment on a car. So let's plug these numbers in. 1 plus 0.03 divided by 12, right? R divided by N. N is the number of times per year you get paid interest. And then 12 times 2. 12 times a year for 2 years. Now we'll need to get our calculator. Now we can simplify a little bit. Let's get our calculator and do the 0.03 divided by 12. 0.03 divided by 12 is 0.0025. So this will simplify to 50 times 1 plus 3 divided by 12. And 2 times 12 is 24. So this is the equation we're needing to solve. 1 plus 0.03 divided by 12. This is 0.03 divided by 12. So add 1 to that. So we've got this. We need to take this to the power of 24 and then multiply it by $50. So if we hit this button, this is X raised to the Y, raised to the power of 24 times $50. So at 18th birthday, we're going to have $53. We fell a little bit short. Oh, wait, we've also got 9 cents. We fell a little bit short of that $2,500 goal to put a down payment in a car. We're in $3 in interest and 9 cents. Answer? Oh, A is the amount of money in the account after 2 years. P is the principal. R is the interest rate. Is that substitute values? And they didn't even solve it. They just got to the equation. 1.0025 times 12t, and our t was 2 years. So I guess they're going to solve that later. But we went ahead and solved it. It's $53. It's not going to be $2,500. Now, if we want to know how long, okay, so they're taking a different angle on it. They're taking a different angle. It's like, okay, instead of making this 2, they said, let's say 2,500 would be $50 times 1.0025 12t. How many years would it take us? we know how much we want. We know how much we started with. We know how much it's going to make in interest. We know it's 12 times a year, but how many years? So that's what they're changing this to. Instead of knowing in 2 years we're not going to have enough, how many years would it take? All right, so that's what we're going to learn how to solve, is how to get that t. All right, but yeah, this is they simplified this. I see how they simplified it. They said, okay, if we're solving this, we can divide both sides by 50. So this 2,500 divided by 50 is just 50, because 50 times 50 is 2,500. And this becomes just 1.0025 to the 12t. So this is an exponential problem because our variable's in the exponent, but this is 50 to the first power, and this is 1.0025 to the 12t power. These are not equal bases. How do we find this out? If these are not equal bases, how do we solve for t? Because if these could both be base 50, we could just set these equal to each other. That's where their problem is run into. So solving with unequal bases. When we had 2 to the x equal 8, we just rewrote the 2 to make it 2 to the third, and so x equaled 3. That was easy to do. The equality property states that given an equation where 2 log expressions with identical bases are each other, the arguments also would be equal. So if we had log base 10 of 2 to the x equals log base 10 of 8, it would be 2 to the x equals 8 because they're the same log, same base. You could also rewrite that as x times log 2 equals log 8 and find that. You find that x equals 3. Right? But what about when we've got 4 to the x equals 7 to the x plus 1? See, that's a problem. We cannot write them in the same base. That's what we're going to learn in this lesson. So let's look at 4 to the x equals 7 to the x plus 1. And here's a video showing how are we going to tackle something like that, because that's very, very different than how we've learned to solve these to this point. So let's take a look in 28 seconds for step 1.
Using the equality property, write each base as the argument of a logarithmic equation. Using the power property of logarithms, turn each exponent into a coefficient on the logarithmic expressions.
Let's go to step 2 here. Notice the x plus 1 has to be in parentheses because all of that's being taken times the log 7. All right, step 2.
Solve for the variable. First, use your calculator to find the decimal equivalent of each logarithmic factor. Find the approximate value of log of 4 and the approximate value of log of 7. Distribute each decimal value to the factor which precedes it. Combine like terms. Divide. Round to the nearest hundredth.
All right, let's look at what they did here. Here, let me just put this up on the screen and just put this in our notes so we can kind of see what in the world are they doing. So they said, okay, if we have 4, that's kind of a funny looking 4. If we have 4 to the x power equals 7 to the x plus 1 power, we can't write these in the same base. Let's take the log of both of them. Log 4 to the x, log 7 to the x plus 1. Then we know that power property says we could just move that out front. So this becomes x times log 4, and this becomes x plus 1 times log 7. So then they say, okay, if we have it at this point, we can just use our calculator and find what those values equal, right? So what is log 4? So if I take 4, the log of that, so I've got x times 0.6020, and they're going like 8 decimals or so, just to keep it as accurate as possible. The next number is a 1, so that rounds down. And over here, we've got the log of 7. So let's find out what that is. Log of 7 is 0.84509804. Okay, so we found out what log 4 and log 7 equals. So log 4 is this, log 7 is this. Now we distribute. So if you multiply x times that, it's just 0.60205999x. Over here, x plus 1, so we'll have two terms. We'll have this 0.84509804x, when we multiply x times that. Now we multiply 1, we just have that 0.84509804. Now we need to move everything that's an x. I mean, this is just like having 3x and 2x. We just got to move it to the other side. So we're going to subtract this amount from both sides. 845098004x from both sides. It's just a bigger number, but it works exactly the same. So on the right side, we know we're just going to have this, the 0.84509804. On the left side, we're going to subtract those two. So let's pull our calculator back up. So the 0.6020599. Oh, I missed something. 0.6020599 minus 0.84509804. So we've got negative 0.24303805x. So to get x by itself, we just divide both sides by the coefficient. 0.24303805, and we're going to get x equals.
So giving me an answer like it's from
All right, so 0.84509804 divided by 0.24303805, but it's a negative 0.24303805 equals about negative 3.4772. We'll go 4 decimals just to bring that down in there. And what did they come up with? Let's see, when they did it, about they rounded even farther to 3.48, negative 3.48. Check your work. This will be fun right here.
Substitute the value of the variable into the original equation. The solution is confirmed.
So there you go. When you take 4 to the power of negative 3.48, you get about 0.008. And that's about the same thing you get when you take 7 to the power of negative 2.48. So example, let's revisit the earlier problem. So if we have this problem we were working on earlier, where we had 50 equals this, let's take the log of both sides. Log 50 equals log 1.0025 raised to the 12t. So this will be the same as log 50 equals 12t times log of 1.0025. So let's get our calculator out again. This is certainly a calculator lesson. unless you know how to do log of 1.0025 in your head. Log 50 equals. So this side equals 1.6989. We'll do 7. We'll do 6 decimals on this, since the rest of them are zeros anyway. Equals 12t times the log of 1.0025. So 1.0025 log. So this equals 0.0010. I'll go 6 decimals also, since I did on the other side. Then we're going to multiply that by 12t. So times 12 times 12. So 1.69890 equals 0.0130125. So that'll round up. And there's a t on the end now because we multiply it times 12 and t. So we just need to divide both sides by 0.13013. And that'll tell us what t equals. So t will equal, let's see, 1.698970 divided by 0.013013. All right, so this is only going to take us 130 years, 0.56, a little over 130 and a half years. So it looks like you're going to be a little short of your 18th birthday, and probably in your whole life, unless you live to be like 147, you won't be able to have that $2,500. And $2,500 won't get close to buying you a set of tires in 130 years from now, I would imagine. So there you go, 130.56. So that tells you you're going to have to put some more money other than that $50 in there, or you're going to have to wait 130 years for it to be worth $2,500, or get a better interest rate, because 3% is pretty low. All right, now they want us to solve e to the 2x equals 30. So remember, base e and the natural log. So that's a natural log. They cancel each other out when solving equations like adding and subtracting cancel each other. So round the solution to the nearest 100. So they want us to solve this equation. These are definitely not the same base, right? And we got base e, and then we got this 30 on the right side. So they isolate the variable, because when you take the natural log of that, this is where they were saying they cancel each other out. So with this, we would take the natural log of e to the 2x. Instead of using base 10, let's use base e. And natural log and e to a power cancel each other out. So this is just 2x equals the natural log of 30. So x equals the natural log of 30 divided by 2, which we can calculate on our calculator. So that one's going to go a lot quicker, actually. So clear this out, 30, and we want to take this natural log button down here and then divide that by 2. So x equals 1.70. That's to the nearest hundredth, because the next number is a 0 as well. So it's to the nearest hundredth. So you calculate it, it's 1.70. But if you have an e, you just use natural log. All right, let's see what it shows on page 3, because we need more practice. So with exponential equations like the interest, a equals p 1 plus r to the t, a is the amount after the exponential growth or decay has occurred. So we know what a is. P is the principal, the starting amount, what you had at the very, very beginning. 1 plus r, that's the rate of change. So if you got a loan that's going to increase by 3%, then the r is going to be 0.03. But let's say it's decreasing, like the value of something is decreasing 3%, then you would use negative 0.03. So anytime 1 plus r, anything of that, if that's bigger than 1, that means it's growing. You're going to have more of whatever you started with. If that's less than 1, it means you're losing an amount. It's decaying. It's going down in value. So if 1 plus r is less than 1, it's decay. 1 plus r equals 1, then it's a linear equation. You have the same amount. It doesn't change if it equals 1. Because your rate would be 0. If 1 plus r equals 1, that means r equals 0. So it's possible to adjust an exponential equation set up for one time increment to find the rate of growth or decay based on different time increments. So if we had a lizard population that doubled every year, we could adjust it to find the growth rate per month or per week or per day. So let's look at this. If we have a lizard population, I guess we'll put this in our notes because this might be useful. If they're showing it here, we're going to need to do this sometime. So they show us this. So I'm putting in our notes. The lizard population over time starts with 14 lizards, and it's doubling every year. Because in this case, T is 1 year. T is a year. Okay, so if there's 12 months a year, look how we can wrap that into this function. So we can take that 2 and take a 12th of it and then put 12 in front of the t where we're changing it. So we'd write that. You still have the 14. And 2 is taken to the 1/12 property, power. And then we're changing this to look at 12 times a year. So this will be changing it to 1 month. Instead of doubling in a year, we get 1/12 of that doubling in 12 times a year. That kind of makes sense. 1/12 of the doubling. So then they simplify that, because if you take 2 to the 1/12, that's the same thing with our switching back and forth between radicals. We know that's the 12th power of 2, the 12th root of 2, I'm sorry. Because the number on the bottom goes outside the radical, the number on top goes inside, so it's really just 2 to the first power. And we can calculate what that is. What is the 12th root of 2? Well, back to this calculator. We're going to use this calculator a lot in this lesson. Let's see. Or if I shift, I have a y to the x, where I can take it to whatever power I want. So if I do 2 and hit that y to the x, it wants to know what root. I want the 12th root. So that is 1.059. I'll go 3 decimals. 1.059. So this changes, or simplifies rather, to 14 to the 1.059 raised to the 12t power. So I just took that and found out what it's equal to. 2 to the 1/12, 1.059. So that's simplified. But this is still measured in years. T is still in years, but we're saying 12 times that because we're taking 1/12 of it. So what does that tell us? It tells us that the 1.059 is the 1 plus r, because that's what's in parentheses, right? And so that means the rate is 5.9% per month. 5.9% per month, because it's 0.059, which is the same as 5.9%. So that's what it tells us. Per month is 5.9%. Per year it doubles. So in a year, it's 100% more. Because it doubles. We started with 14, we're going to have 28 at the end of the year. It doubles. But per month, we can calculate it to be 5.9%. So that's a way we can figure out percentages like that. And then they checked it, said, what if we use t equals 1 year in the original equation? Well, 2 to the first power is 2, 14 times 2 is 28. Well, what if we use our 1.059 12 times in a year? So if we say, okay, still just 1 year, so it'd be 1.059 to the 12th power, which equals 2. 1.059 to the 12th power is 2. So we still end up with 28 lizards after a year, even if we changed it to a monthly rate. So it is the same one we started with. Okay, so now they want the value of a sailboat decreases 12% every year. The sailboat's worth is calculated using this function. All right, so let's write down this function because they want us to try to convert this to see the decay per week. All right, so notice this is less than 1, which means it's decaying. So it'd be 1 minus 12. That's a 12% loss per year. But if they want to know per week, we need to convert this. So the worth is still worth $50,000 at the beginning of the year. But now this is 0.88 to the week is 152, right? 1 over 52. There's 52 weeks of the year. And this would be 52t. So we can take this 0.88 and find what the 52nd root of that is, right? Because we take this right here, 8 over 152, write it as a radical. That's the 52nd root of 0.88 to the first power, which is going to be a very small number. So 0.88 shift this y to the x. So I want the 52nd root. So it's less than 1, 0.9975. And I'll go ahead and put one more. I'll go five digits, 99754. And the next number is a 4. So that means it would round down. That one's a 4 there. So, all right. So if we replace that, so per week, it's decaying what? 1 minus r equals 0.99754. That's negative r. If we subtract 1 from both sides, negative r equals, and let's get our calculator again on that to make sure we don't mess anything up. We got 0.99754 minus 1, negative 0.00246. So if we divide by negative 1, the rate of decay, well, the rate of decay, it is a negative rate of decay, but it's 0.246%. It's less than 1%. It's 0.246% per week, which for the whole year is going to be 12%. Let me get rid of the calculator. For the whole year, you're losing 12% because this is 1 minus 0.12 or 12%. But in a week, we're losing less than 1/4 of 1%. Decay. So I guess we can make it a negative 2.46, less than 1. Let's see what they get. See if we got that calculated right. Check your work. They just rounded it to the 0.2. I went to 2.46. I had it a little more accurate. So it decreases 1/5 of 1% every week. All right, here's our lesson summary. I'll be interested to see what our problems look like. So to solve with unequal basis, we can write it as a log. Solve for the variable, check your work. Finding rates of growth or decay for different time intervals, we just have to convert it to whatever the time interval is. All right, so let's do one more thing before we get. Let's do some of their practice problems before we get out of this. 5x equals 20. Perfect. This is a good one for us to practice with. We need some more practice. We haven't had very much. 5 to the x equals 20. Okay, we cannot write those as the same base. So this is where we need to go log 5x equals log 20. So this is the same as x times log 5, because remember the power rule says we can just put that out front. Equals log 20. So really, we'll divide both by log 5, whatever that is. So x equals the log of 20 divided by the log of 5. And we need to put that as a number. And we can calculate that. 20 log divided by 5 log. So that equals 1.86 if we go into the nearest hundredth. Let's check our work. 1.86. Just worked exactly. Then they went ahead and did log 5 and log 20 right there. You can do it either way, because either way you're going to divide it over there. I'll see another one. Oh, this will be a good one. Let's do this one as well. 6 raised to the power of x minus 7 equals 9. Okay, again, we can't write these as the same base, or that would be last lesson, right? So we're going to take the log of both sides. So this moves out front and becomes x minus 7 log 6 equals log 9. We can take the log 6 and we can go and distribute it first. Let's just distribute it first. Log 6x. Pardon me, that log 6 of x minus 7 times log 6 equals log 9. Now let's actually put some numbers in there for that. So let's get our calculator back up here. Okay, so let's see what log 6 is. Log 6. So this is 0.778115x, because all we do is just convert that to a decimal, minus 7 times that. Take that times 7. Minus 5.44706. Will 5 decimals be consistent? Oh, it's 5 decimals on the other one. So that's 5 decimals, and the 8 makes it round up. And log 9 on the other side. So log 9 is 6.679. Well, let's go to round up. 7970. We need to move this to the other side because it doesn't have an X. So we'll add 5.44706. 5.44706. So we've got 0.77815x equal to, let's see what that is when we subtract this. So we go 6.67970 minus 5.44706. So this is going to equal 1.23264. We divide both sides by the 0.77815. So divide this by 0.77815. So x equals 1.5 1.58. And they've been rounding it to 2 decimals, so we'll leave that at 2 decimals. 1.58. Let's see what they got. Check your work. Oh, we're way off somewhere. Wait a minute. What did we do differently? X minus 7 log 6. Did we get first log 6? We did get that. So we had this 0.7711x minus 5.44. Oh, our log 9 was wrong. Wait, did I write something down wrong for log 9? Let's go back there.
So that is this one right here. One down.
So this number's wrong.
Less than 3 assessment. So after you read less than 3, do your study.
Oh, yeah. I don't know what I wrote some weird number down over here. Don't know how I got that. Log 9 is equal to 0.95424. So, yeah, all this is wrong. And that's why they have to check your work to see what you messed up. No, I think this was right here, the 5.44709. We can double check that real quick. Yeah, 5447. Okay, that part was right. Let's just go back to our paper here. So I need to add the 0.95424. Okay, so 0.95424 plus 5.44706. So this is 6.4013. And that's what we're dividing by the divided by 0.77815. Oh, that looks a lot closer to what they got. 8.23. So somehow I hit the wrong button, didn't get log 9 correctly. And that's x equals 8.23. And that's what they got as well, 8.23. All right, what's activity 2? Isotope decays the rate of 40% every decade. Change that to annually. So you just write the formula and then make it 1/10. The rate of decay would be at the 0.6. Rate of decay is 40% every decade. So 1 minus the 0.4 is 0.6. We did a couple examples of that. So is that all of the? Oh, there's more of them down here. 2 problems there. 55% a week, and change that to daily. So you do 1/7, and then 7t. So that's all the practice problems we have. We have 5 here. Got a few more there that you can do. And then a couple on the next page. Let's look at the assignment that goes with this week. Car is $20,000. Decreases 8% a year. Find the rate of decay per month. So if it loses 8% a year, what does that calculate to when we change it to per month? Here's a base 3 and a base 7. What does x equal? Okay, Dylan solved this equation. What's the first place he made a mistake? Where did he make his first mistake? Now, again, you may have a different problem because Buzz has a bank of problems to choose from, so it doesn't give everyone the same problems. But this is just the ones Oh, it looks like there's only 4 problems this week. Don't even have 5. $175 in a savings account, trying to save $3,000, makes 3% a year, compounded monthly. How long does it take you to earn $3,000 if you start with $175? I bet it's a lot longer than 8 years. I bet you can rule that one out. I'm just betting you can rule out 8 years. So can I cancel that out? There. Answer eliminator. There. I'm eliminating that one right there. It's not going to be 8 years. Do you know you had that answer eliminator up here? And you can highlight. So I want to highlight that. See, you can highlight things. You know, whatever you find that you need to remember, use that highlighter. Use that answer limit. And there's a calculator right up here as well. If I want to know the log of 9, I got to hit log first in this calculator because it shows parentheses, log 9.9542. If I'd use this calculator, maybe I wouldn't have messed that one up. I don't know. But yeah, you have the calculator you can use right here. And you can print things if you have a printer. So, all right, 4 problems. Wow. And we're only doing 1 lesson this week. Like I say, I'm going to give us a break the last 4 weeks. We're going to cut this down. Next week is Thanksgiving, but when we get back, we'll just do a couple of more lessons. And then you see the semester exam there. It's there. I wonder if it does it let me click the semester exam. It shouldn't. No, it's not available yet. Not available because we're not to the semester exam, but it is there. So, all right, everybody. Have a great Thanksgiving. 4 questions. You could probably have this one done before your next class. So you got some time now to work on that before your next class, and have fun with this. This is a little different than last week because now we're working different bases. But that's why we've learned about logarithms and exponentials because now we're needing to combine them. We're having to use the logarithm to solve the exponential because the bases are different. But it's not that bad a process. Just make sure you write down the right numbers like I did when I punched in. Maybe you should check twice before you write it down. I don't know. I don't know how I got log 9 to be so off like that. Maybe I hit the button twice. That could have done it. So. All right. That's all I got for you this week. We're gonna slow down, take it easy the last few weeks of the semester. And take a breath and be refreshed for the holidays. So have a great week. It's a B day Friday. So we only have class on Wednesday. And I don't know that anyone in here has to be here Wednesday, but you can come by and say hi. All right. Have a great week. Happy Thanksgiving.